billions of suns blaze across our galaxy, each offering the possibility of alien worlds teeming with life. Yet, when we look up at the night sky for signals, we are met with silence. This begs the question, is life extremely rare or just hard to detect? Since the dawn of civilization, we have gazed at the stars and wondered, are we truly alone?
And I think that that collision of ideas in cosmology is very vivid when you bring it together with biology, which is that we are physically insignificant, but it is possible to argue that we are remarkably valuable, notwithstanding our physical insignificance, because it's possible to at least argue that the number of civilizations in a galaxy like the Milky Way might be, on average, 1 or less.
Our galaxy, the Milky Way, is estimated to contain between 100 and 400 billion stars, and at least as many planets. A new study suggests there could be 60 billion planets in our galaxy's habitable zones, regions capable of supporting life. For a planet to support life as we know it, it must have liquid water, energy, and nutrients. These basic ingredients appear to be common throughout the universe, but we have yet to find evidence of other civilizations. So, where is everybody?
Well, it's the Fermi paradox. So the Fermi paradox, going back to the great physicist Enrico Fermi, is essentially the question, where are they? You base that on the observation that, let's say there are somewhere between 200 and 400 billion suns in the Milky Way, something like that. We think a lot of them have planets. Many of them have potentially Earth-like planets. So you have 13 billion years of time. You have hundreds of billions of suns, probably trillions of planets. And so it is a reasonable question to ask, why not? Why has a civilization not arisen ahead of us? So let's say a billion years before us. Why has no civilization escaped its home world, apparently? If you could build one of these self-replicating machines, how long would it take, given some reasonable technology, to move between star systems? How long might it take to replicate itself? And you end up with calculations that say that if someone had done that, even a few 100 million years ago, those machines would be everywhere.
Research in the Fermi paradox often considers that advanced civilizations might not last long enough to be easily detectable. They may be transient on a cosmic scale, meaning they arise and then disappear, due to factors like self-destruction or natural catastrophes. Researchers argue that if technological civilizations routinely self-destroy or otherwise burn out, then the chances of overlapping with our own window of detectability become very small. This short lifetime would explain why we don't see evidence of them today.
So the pre-spaceflight era, or pre-interstellar flight era, you will hit problems which are probably common to all civilizations because they're just part of the laws of physics. So one of them is the challenge you pose to the climate of your planet. As you industrialize and build a bigger civilization, you'll use resources, you will affect the atmosphere of the planet and so on. So there's a challenge and you have to manage that they're just not able to navigate the challenges that industrialization and the development of nuclear science and so on raise. We haven't passed that test yet.
Many people in the general public feel the Fermi paradox needs no solution because they believe aliens have already visited us. However, in science, extraordinary claims demand extraordinary evidence. One related idea is the zoo hypothesis, which suggests that advanced extraterrestrial civilizations do exist, but intentionally choose not to interact with us, much like zookeepers who keep animals in a zoo. Recent estimates using the Drake equation suggest that the Milky Way may host very few detectable civilizations, potentially only one: the human race. While earlier estimates were much more optimistic, this updated perspective takes into account the possibility that civilizations may not last long enough to become a spacefaring civilization. Ultimately, The Great Filter hypothesis should serve as a wake-up call. It reminds us that if detectable civilizations are indeed rare, perhaps because many self-destruct before reaching advanced spacefaring stages, then we must be vigilant in safeguarding our own survival. In essence, if we are alone in the Milky Way, our failure to overcome our own challenges could extinguish the candle of consciousness in our galaxy forever.
So multiplanetary and then interstellar. Then you have to have solved these problems that cause us to be violent, predatory. And so he suggested that as you make progress and become more powerful and navigate these problems, as we said, these filters that may lie in the future. So you have to, for example, learn to get on as a planet, as a civilization, as one civilization on one planet. And so they would not expect a violent sort of interstellar, a violent civilization to come in, as you see in science fiction films, and try to take over everything, because violent civilizations like that don't really solve the problems that are necessary to build interstellar spacecraft. We have not yet observed anyone. What might the reasons be? And that's an interesting exercise, but it's not to say there isn't anybody out there. It's to say there's an observation here that we don't see anyone at the moment.